All right, hello. So today I'm going to be talking about rotation within the z-axis, and I was kind of doing some lines there. Um, so we're going to have to use projection in order to use the z-axis. So you can think of projection as like, I don't know if you did in art in middle school or whatever, or whenever you did art in school. If you did art in school, um, you had these like a focal point, and then you had like lines drawn, and then you can figure out the perspective of the image based on, drawing a line from here to the dot and then to the next dot, that's kind of like our, kind of what we're trying to program, right? Is that perspective or projection. So I'm going to go ahead and get a green color here. So this is like, we're going to draw a square, and I realize that this blue point is off. Uh, so I'm going to erase it. I don't know why that bothers me, but it does. And then put it right here. Boom. Now that's good. So in order to, you know, do some projection like that, first we're gonna have to. So these are the 4 points of the square that we're gonna make, right? Um, if you think of a square as encompassed by a circle, that's how you're gonna have to start thinking of everything when you get into rotation. This point is 90 degrees from this point. This is 90 degrees from this point. This is 90 degrees from this point. This is 90 degrees from this point. Or you can think of three, you know, 360 divided by 4, or I'm sorry, pi divided by 4 would be 90 degrees. So, yeah. Um, so, um, what you're going to need to do now is you're going to have to pretend like it's a right triangle. This is our focal point, the center, right? So I'll make that some other color. Why not pink? Just a bright color that we can all see. So that's the focal point. Our focal point is going to be the center, like I just said. And we're gonna make this like a right triangle from the center. So from here to our point to there, we'll make a right triangle. What we're trying to find from each point is this angle. In order to find that angle, SOHCAHTOA. You're gonna have to find, you need the opposite, which we can find, if we know where the center of the screen is, and we know where the point is, we can figure out the opposite. We can figure out the adjacent as well. And with the opposite and the adjacent, if we divide the two, uh, in atan, we can figure out what this angle is right here. And then what we can do is draw a new point, that might be, a little further out, but with, so as you get further out, that angle kind of like might increase. So we can draw like the same triangle if the point is further up on the z-axis, right? It might be like right there. Then our new point, would be right here if we're like looking further back. Um, but if we're, getting further away, you know, we can take that same angle and like kind of like scale it down and make our new point like right here. So we're taking the triangle and just kind of like scaling it. Um, we're um, was I saying? I know we were saying we were scaling the angle, but we're not. I'm sorry, we're not scaling the angle. We're just scaling that triangle that and making it keep that same angle, right? Uh, so we use SOHCAHTOA. I think I explained that wrong. We use SOHCAHTOA. Keep changing the color to find this angle. And once we find that angle, we can scale that triangle. Scale a triangle that has the exact same angle, the same right triangle, and we can make it bigger if we're looking further back with the same angle, or we can make this triangle smaller, if it's further away. But it's always gonna make sure that it always has the same angle. So in order to do that, so first thing first, Like I said, a square has 90 degrees to each side, so we can do that. And it's pi divided by 4 because what is 180 divided by 4? 90? You know? Oh, wait. 180 divided by 4 is, you know, pi divided by 4 is, I'm stupid sometimes. All right. All right. So let's change this to degree 90. Actually, I'm stupid a lot of the time. We're going to have 4 points instead of 3. And we're going to actually draw it right here. And it's a little off because we need to make this 3 instead. Now we got a square. So, yeah. I'm still laughing about 180 divided by 4 is 90. Oh well. You know, it's all right. Um, okay. So we drew our 4 points. We kind of did the same concept we did with, the isosceles triangle. This time we're building a square instead. And instead of doing 120 degrees, we're doing 90 and we're offsetting it like that. And yeah. And we're actually going to get rid of this. We got rid of that rotate because we're going to rotate across the z-axis. And we're going to do all our rotation stuff right here. So first, we're going to have to find the adjacent and the opposite. So to find the adjacent, we can do, which is this top part, A. That's opposite. So we're finding the A. We can do the width of the screen minus whatever x is of that point. So we're gonna do, or this, we have the center point right there. Center minus point 0 dot x. And we only really need to find this for 1 point because the angle is going to be the same for all the points. We could find the angle for each point, but we don't need to, so we're not going to. Just more work. Center y. Yeah, so that should find, so that's, we found the opposite and the hypotenuse. I mean, hypotenuse. Opposite and adjacent. And adjacent. Then we can get the angle. Opposite divided by adjacent. Bada bing, bada boom. And then we're going to do a little thing here. Call it y scaling, I guess. I don't know. Because we want, like, while the projection is coming in and out, as it's getting closer to you and the back's going forward and the forward's going back, so we're trying to rotate it like this. The y, the height is going to get smaller and bigger. It's really weird looking directly at myself. This is probably creepy. Yeah, so it's going to be kind of like that. So y scaling, I guess I'll call it that. Looks weird without having an underscale. Underscore. Underscale. Underscore. I don't know. Undertale. Equals. I'm looking at previous code just to make sure I get this right. I think I just did cosine f and like put the rotate thing in here. So now if we did points 0 dot y times y scaling, no, times equals, that we should just, go up and then go down, and yeah. Just for that point anyways. Let's do it for point 0 and point 1, which is like the two bottom points. Up and down. There it goes. That's it. That's the whole thing. No, this is it. You did it. That's 3D. It's not. It's not. Um, yeah, that's the one part. And we're gonna have to find our Z, which is gonna be a little more complicated. Sine F, rotate in here. And we're gonna change this up a little bit. That's why I kind of put extra parentheses times the radius. And now we're gonna do something for X and Y right here. And we're gonna do a minus equals. And we're gonna have another sine F angle times Z. I don't know why I put that in quotes. And then cosine F angle times Z. And we're gonna do the same thing for point 1. So this is for the x-axis. It's gonna get further apart and closer up. As you get closer and away from the screen, it's gonna be going like this. So for one side, we want it to go towards the negative area, and then for the other side, we want it to go towards the positive area. When we're scaling, or when it's going in and out. So that's why plus 1x and minus the other x. Yeah. Boom. And that's gonna look kind of goofy right now because it's just kind of like flipping only the bottom part and not the top, so it looks kind of weird. So we're gonna kind of do the same thing, and I'm going to make this a loop so it doesn't look so repetitive, but I'm just doing this so I can see what's happening doing it this way. So yeah, and then make this 3, 2, 3. Boom. So now we're doing that for the top and the bottom. And you notice like our angle, our projection angle is super wide, and that's why it looks like going in and out really, really wide, and it's getting really wide and getting really small. Well, we can change the projection angle right here if we just divide this by like some whatever number, or yeah, just to make it a little smaller. And now if we do it, now it doesn't look so like stretched out because we changed our projection angle there. And just to clean this up, let's just make this a loop. 0 to 4, 0 to 3. Let's actually go like this. I minus 1. And then I think. Who knows? Let's not. Just do that real quick. Make this 1 instead. I think that's good. And then for the Z, we're not going to be able to like really. Yeah, we can do the same thing. Kind of. I minus 1 and I think, hopefully. Whoa, what did we do? They're not looking so good. It's not right. it isn't right. The tricky thing about the loops. Zero, 1, 2. Oh, I did. My brain is not working. It's in... Help. I've fallen. Oh, what the... Is it because... I don't know what it's because. What? My brain can't figure out why this is wrong right now. I think I've overdone my thinking for the day. This looks so right, but it doesn't work. Yeah, it should go to 0. Then it should also do 1. I think it's missing a point because it's not going to go... I don't know. I'm going to do one of these. I minus 1 and then I. What does that get? Should get 0, 1. I don't know. 0, 1 and then... should be... Let's make this easier on myself. No. Oh, there's a point. Okay, I think I see what's happening. When it gets from 1 to 2, like the in-between point, like that's gonna not really work. Because it's gonna do 2 minus 1. Oh, yeah. Yep, yep, yep. Yep. Let's just go to 2. Yeah. And then let's make the same loop, but instead start at 3. Yeah. Oh, 4. Yeah. Can I use my brain? I think this might help me. 0 to 2. 2 to 3. So I can visually see. Well, 0 to 1. Brain doesn't work. Oh, because I'm doing I minus 1 here. Yeah. I don't, that's weird. So I really have to do... Yeah, this is not gonna work. I don't know. I can't think about how to loop it to where you don't show it like that right now, but just know that that's how all this works right now. So you're trying to clean it up right now. Go away, stupid Kodak issue.